Here, I already prepared this to save time, and first we will show if we have ISA, and then how can we encrypt it. And this, suppose we have RSA key here. It's the generation process. Let me see whether we have it or not. So I want to see whether I have cut RSA key. Okay, I already have ISA here, but I'm not sure whether I have tried this several times, and I want to make sure the public key is exactly the public key corresponding to my private key. So I run this command again. Okay, it's good to verify this. Here, this command, there's no encryption in this command, but I have tried use some encryption for protecting my private key. So to make it easier, I will directly use it in plain text form. Then I take, so after these two steps, I have private key and public key. And then we have, suppose I have this file. You have already seen this sample file. This is a file. It's just a short message. I want to sign. And then what we do is we use this command. OpenSSL and this PK utility. Then sign, I need to give this input file and also specify the signature. And also here, I need to give in, okay, it's in key, that's the input key. You see it's RSA key.pom. So it means I encrypted with, sign it with my private key. Okay, I get the signature. Let's look at how it looks like. So this is a signature. And now suppose I send this information, this signature, together with the sample to any of you, and suppose you already seen my public key for RSA, then we can use this command this line of command to verify it. The format is quite similar, but here it's a verify, it's not sign. And here I need to specify the input file, this original message, to compare, right? And then I also need to give in this, provide the signature of this file. And here I give this public key in, this pub in, it means the input key is a public key. Then here you see this in key, this RSA key.pub. This is a pub key I previously generated. Then with this, you see it's a signature verified successfully. This is, this is how it works with the public key to verify the signature, which was generated by some private key before. And this is one information for you, like if you search around this verification, use this PK utility, this command, and mostly you will see here it's this just in key and then rsa.key.pom, or like just key.pom. To me, it makes no sense because it gives like the verifier does not have any access to the original order key, so it can only access the public key. So it's just like if you search around for this verification process with a PK utility, then you always get you don't have this this version. And so I've mentioned this in the file. So this we just show it's okay. It's only for small message, and if I want to sign on a big file, then how it works? It does not use this PK utility. It directly uses this digest command. Here I have a file. Like I just took my slide. Let me show you. Open this large. In fact, it's just my slides used for the lecture. It's not very big, but it works for this demonstration. It's several megabytes. And then how can we use this? We use this command, OpenSSL digest, and we need to give in this, provide this hash function, then sign. Here you see it's this RSA key.pum. It's the private key. And alt I signate just here as with L to indicate it's a large file. Then this is the signing process. If we want to see is signal L, then you see it's the size is pretty much as before because we use hash, and the size is controlled properly. And then if we want to verify it, here you see it's verify and the public key, then given the same signature, but I also need to provide this large sample file. Then okay, verified. Okay. This in fact is used in daily life. How large files is signed and verified. But with this hash function here, and if we want to have a signature, we want it to be two things. This signature is bound to the signer, a specific entity. This is one important feature. Another important feature is the original message, original file should be the same, bound to the signature as well. So this signature bound to the message, bound to the user who signed it, right? Then in this case, what could be going wrong is, suppose if we use some weak hash function here, we mentioned, then we might get some collision of weak hash function like MD5 or MD or SHA-1, but that's more difficult to find the collision. But still, it's possible to find the collision. Now here, if we have two files, if we have two files M1 and M2, they lead to same message, same hash. Then we sign this hash with the secret key, the private key, and then we send to Bob. For Bob, of course, verifying is not a problem, but Bob can change the original this message. Claim, okay, this message is sent from Alice. The original message is sent from Alice, right? That's not good. That's what we try to avoid. And to show it does work, let's see. You have seen these two PDF files. There's open SHA-1.1 You have seen this file before. This is SHA-1, and if we have SHA-2, it's another file with different color. And here, if we use the same command, but unfortunately, we use a weak hash function, like here. Of course, we can sign it, and anyone with a public key can verify it. It's the same as before. And if we change this file into another PDF file, okay, now we have two signatures. Signature 1 is bound to SHA-1, and signature 2 is bound to SHA-1, 2. So let's see what this two signature looks like. This is signature 1. This is signature 2. You cannot see it clearly, but we can use OK. They are the same. Not surprisingly, they are the same because we know the SHA-1 and SHA-2, SHA-11, SHA-12, these two PDF files, they have the same the SHA hash. So that's the reason.